Welcome to lesson 6.1a. We are going to start talking about radicals. So first we're going to go back to area because that will help us develop our radicals. And we remember from last year that when we have a irregular shape, we can attack it in one of two ways. We can either surround and subtract, or we can cut it up and add. So our two techniques are to surround and subtract, or cut and add. So it just depends on the shape, which way is easier. So when I look at A, I go, hey, that's made out of a rectangle and a trapezoid. So I like to cut and add. So I go, okay, rectangle, trapezoid. I remember how to get the area of a rectangle. Base times height, 2 times 3. So 2 times 3, that's going to get me a 6 in here. And then a trapezoid, I have a base of 3 and a base of 1 and a height of 1. So I'm going to go 1 plus 3 divided by 2, the average of the bases, times the height. So I get that this is 2. If you don't like the trapezoid, you could have always cut it up into another square and 2 triangles. So here I get 6 plus 2. That total is 8 units squared. Okay. When I look at B, I would probably, because it's tilted on the diagonal, I would tend to surround and subtract. So I'm going to surround it with a big rectangle. And then I'm going to subtract some pieces off. I see a trapezoid on the top, and then I see a rectangle and a triangle, and then 2 little triangles. Okay. So my total piece, my total rectangle, 1, 2, 3, 4, 4 by 1, 2, 3, 4, 5, 6. So now I'm going to start at 24, and then I'm going to take off some pieces. So now I'm going to look at the trapezoid up here. 1, 2, 3, and then 1, 2. So I do average of the bases, 3 plus 2 divided by 2, times the height, which is 1. So I get 5 divided by 2, so this part is 2.5. So I'm going to take off 2.5. And you can see that with the 2 squares and half a triangle. And then I see a piece over here, this triangle right here. Base times height is 2 times 1. So 2 times 1 divided by 2 is 1. So I'm going to take off another 1 there. And then over here, this piece in the corner, that is a triangle 1 by 1. So 1 times 1 divided by 2, that's a half to take off. Okay, so let's see what I've done so far. I have done the trapezoid, and I did this lower triangle and this triangle. So I still got to take away this other triangle over here. This is a 2 by 1. So 2 times 1 divided by 2 is going to also give us 1. So 1 for there. I'm going to take off 1 for that triangle. And then I've got the square 2 times 2, which is 4. So I'm going to take off 4 from there. Okay. So when I subtract all my numbers, 24 minus 2.5 minus 1 minus 0.5 minus 1 minus 4, we get to 15. Okay, this next one I would probably surround and subtract again because it's tilted. I don't have to work so hard though because all of the outside triangles are the same. So my main rectangle, where is it square? 1, 2, 3 by 1, 2, 3. So 3 times 3 is 9. And then I have the same triangle multiple times. So I'm starting off with 9. and then I'm taking off these triangles that are 2 times 1 divided by 2. So they're all 1s, and I have 4 of them. So 4 times 1, so I get 5 units squared. Okay, so that is our basics. We can surround, subtract, or cut, or add. We learned that last year in Module 6, I believe. Okay, now we're getting into create ABC, square ABC. So we know a square has the same side lengths. Using a line segment AB, each with vertical dot must be on a dot. Okay, so I know that the corner of a line is perpendicular because it's 9 degrees. And I know that if I have a slope that's A over B, then the perpendicular slope would be negative B over A. Some review from prior modules. So here I can look at this slope. I know this is going down 1 and over 1, 2, 3, 4. So this slope is negative 1 over 4, which means the perpendicular slope would have to be 4. Okay, so up 4 over 1. Up 4, 1, 2, 3, 4 over 1. I get a dot there. Same thing here, up 4 over 1. 1, 2, 3, 4 over 1. And then I can make my square. Maybe. There we go. Okay, so A, B, C, D. CD is parallel to AB, so it's negative 1/4. And AD is parallel to BC, so it is 4 over 1. Okay, the area of the square. Now, that's a little bit harder, not too hard. We can surround and subtract again. And I get that my big square is 1, 2, 3, 4, 5 by 5, 25, minus 4 of the same triangles. My triangles are 1, 2, 3, 4 by 1. So 4 times 1 divided by 2 is 2. So I get 25 minus 8. I get 17. Okay? So what we're seeing is that, hey, my square is kind of tilted, but it still works out. And later on, we're going to be looking at how this side, if this area is 17 and it's a square, then this side has to be square root of 17 and this side has to be square root of 17. If I look, this side is 4 on the triangle, this side is 1, and those are related because 4 squared plus 1 squared is 17. Okay, so when we're looking here, area of 2, well, I can't draw. I have to think, what times itself multiplies to 2? Well, that's not an integer because it's not a perfect square. So if I want an area of 2, I have to kind of create it on a tilt. Okay, so if I think here, if I cut it up, I have a triangle here and a triangle here, and this top triangle is 2 by 1 divided by 2. That'd be area 1 and then area 1, which makes an area of 2. If this area is 2, the side length is the square root of 2 because the square root of 2 times the square root of 2 is 2. Now 9 is a perfect square. So area 9, that means the side lengths would be 3 each. I can draw that straight up and down. Okay? Here, the next one, if I have an area of 18, this would have to be the square root of 18. So I have to have, like, I'm thinking I have to have it tilted. I know that. And this top area has to be 9, and this bottom area has to be 9. So how can I get a 9? Well, if it's a triangle, I'd have to go 3 times 6. So I'd have to make it so it's 6 wide. 1, 2, 3, 4, 5, 6, and 3 high. Okay, if I look at that, what's happening here, if I look at the sides where I'm surrounding the triangle, surround, surround. Right, here we have 1, 2, 3, 4, 5, 6. 6 times 6 is 36, and then we're taking away 4 triangles that each have an area of 4.5, so we're taking away that other 18. Okay, this is a 3, and this is a 3, and this is a square root of 18, because 3 squared plus 3 squared is 18. Okay, that may seem difficult to you, but what you really want to just concentrate on right now is if it's not a perfect square, it has to be tilted. If it's a perfect square, my sides are vertical and horizontal. The sides are vertical and horizontal to each other. Okay, here with the 2 and the 18, they were tilted. I had to think to get the side on that one. I know the side is a 1. The side was a 1. And I had to bust something on a tilt that was 1 by 1. And on this one, the side right here is supposed to be the square root of 18 to get an area of 18. I had to bust a tilt here of 9 by 3 by 3, which is 3, 9, 3 and a 3 to get 9 squared, 9 squared. Okay, we're going to get a little bit more into that when we get Pythagorean theorem a little bit. So first I want to think of perfect squares. So a perfect square is like when I go 1 squared, I get 1. 1 is a perfect square. 2 squared, I get 4. 4 is a perfect square. 3 squared, I get 9. 9 is a perfect square, and so on. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. Okay, so when we square a whole number, we get a perfect square. So a perfect square is created when you square a whole number. If the area of a square is a, then the side length is the square root of a. Okay, we say the square root of a, or it's also known as a to the 1/2. It's a fractional exponent. When we square a square root, that's inverse operations. If I get the square root of a and I square it, I end up with a. Okay, so we're going to list our first perfect squares. We're going to start doing up there. 1, 4, 9, 16, 25, 36, 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. We should have these memorized. We need them. Okay? And then we are applying it. If your area is 1, your side length would be the square root of 1, which is still 1, because 1 times 1 is 1. If your side length is 2, this would be 2 squared, which is 4. Okay, so we're going backwards and forwards. Here, this would be the square root of 3, which you can't simplify. Square root of 3, 13, squared is 13. So pause the video, fill in the chart, and see if you get them right. 20 squared would be 400. If the area is x, the side's square root of x. If the side is y, the area is y squared. If the area is 16x squared, it came from 4x times 4x. If it was 49, it came from 7 times 7. This would be 0.7. It's almost half the amount of decimals. So it's 2 decimals. It's going to be 1 decimal spot. 0.07. 0.007. 8 squared is 64. 0.8 squared is 0.64. Here I have to get 0.0064. This is 1, 2, 3 decimals, so this is going to be 6 up here. 1, 2, 3, 4, 5, 6 decimal spots. Okay, so these are perfect squares. I can sit there and know my perfect squares, then it would be fast. I know that's the square root of 15 times the square root of 15, so I get 15. Or if I don't know, I just think of something that goes into 225. So I know quarters go into 225. So I think 225 divided by 25. Okay, 25 square root of 25 times square root of 6. Two 25 divided by 25 is 9. Sorry. So I pause there for a second. 9. And I know that this is square root of 5 times square root of 5. That's a match. And this is square root of 3 times square root of 3. So from these two, I get a 5. And from these two, I get a 3. And 5 times 3 is 15. So if you don't know your perfect squares, you can always break them down. 625, I know that's 25 times 25 because I know my perfect squares. But if I didn't know that, again, I can go, okay, I know that 25 goes into 625. And then you're going to immediately get it out if you see it. But if you didn't see that, maybe you just said, okay, 5 goes into there. You can do that way too. 5, 625 divided by 5. 125. And you go, okay, hopefully you recognize 25 goes into that. That would be square root of 5 times 25. And 25 is square root of 5 times square root of 5. So from these two, we get a 5. And from these two, we get a 5. And 5 times 5 is 25. So if you don't know your perfect square, you can still break it down. Okay? Like this one, I might not know off the top of my head that that's 50. That's square root of 50 times square root of 50, so I get 50. I might see a 25 in there and 100. Great. 25 and 100. Maybe I recognize that those are perfect squares. So I go, oh, that's 5 times 10, which is 50. If I don't recognize they're perfect squares, I can always break it down. That's 5 times 5. That's 5 times 20. That's 25 times 4. That's 2 times 2. So I get a pair of 5s, another pair of 5s, and a pair of 2s. 5 times 5 times 2 is 50. All right. Here, this is the square root of 18 times the square root of 18. We get 18. Or if I don't know that, break it down. 324 is divisible by 2. So I get 2 and 162. That's divisible by 2. 81. I should recognize that 81 is a perfect square. But if I don't, that's okay. Square root of 9, square root of 9. Those break down to 3s. You can break it all the way down. I have a pair of 2s, a pair of 3s, a pair of 3s. 2 times 3 times 3, you're going to get your 18. So either way. Okay, here we know if it's a squared, the square root cancels, this is just going to be an a. Here we have to think, what times itself gets you 4? That's a 2. And what times itself gets you an x squared? So that's 2x. So a and 2x. 64, I know that's the square root of 64 is 8. and the square root of b squared is b. I know 144. So all I have to do here is I know it's 12 and there's 1, 2, 3, 4 decimals, so it's 0.12. Here, the square and the square root cancel each other, so we get a plus b. Number 21. Marissa says that the square root of 9a to the fourth simplifies to 3a, but Ryan disagrees. Well, let's see. If I went 3a times 3a, I would get 9a squared. I wouldn't get 9a to the fourth. So Ryan is correct. The square root of 9a to the fourth is going to be 3a squared, because 3a squared times 3a squared gets us our 9a to the fourth. Okay, so here, this would be a 3a squared. All right, here I have to think 49. 49 is 7 times 7. What's going to get me to x to the 6 is x cubed and x cubed. So I get 7x cubed. Okay, so when I see this, I break it down. So why don't you pause the video and try the next 4 problems and then come back and check. Square root of 25 is 5, and square root of x to the 10th, that's x to the 5th. This would be 0.7 x to the 6th. This would be a to the 4th and b. This is not true, because if I have 3 plus 5, I would get 8. 8, the inside would be 64. But the inside of this is 9 plus 25, which is 34. So this is not true. So nope. Okay, hit save, finish up your notes, and turn it in.